First off, we have these excellent tables at the beginning of our textbook. As I said in previous week sections, please make use of this. Hopefully, after covering this chapter, you will be very familiar with the normal, the chi-square, and where is that? Oh, I just went too far. And the beta distribution over here. And I'm expecting you to, if you cannot memorize the PDF for all of them, at least memorize the PDF for normal. And of course, memorize the mean and variance for all these distributions, so you can save yourself a ton of pain and trouble in exams. Just to keep yourself from memorizing, from looking up these things when you can be just memorizing them. Okay. Now, the other thing I want to point you to is on the back cover of the book. I'm sure we came across this in lecture. We have the nice distribution tables. And what are these for? That's the first question we need to answer. Well, in fact, let's start with the normal table. The normal table is here, so when we don't have access to, say, statistical computing, which only has been around for, I guess, 20 and most 30 years or so. In the good old time, people just used this table to find out, say, what is the critical value and what is the corresponding probability. So they can only, say, get an approximate value. You can't have something like 0.4603. You only have 0.2 or 0.7. So you only have approximates. So but still, we need to learn these stuff, because more often than not, we will not have a computer on hand when we are encountered with a statistical problem. And the idea is you need to familiarize yourself with some important points in these graphs. So for example, this one, so bear in mind, this 1.0495 is a very important point, and it corresponds to 1.65. We will revisit this very soon, about 20 minutes or so, and you will understand why I am highlighting this. And in the meantime, I really encourage you to think about, well, why is this number really important? Okay. And apart from the normal table, we also have the T table. As you can see, it's also corresponding to a bell-shaped distribution. We have the chi-square distribution, and the key thing is it has to be located on the positive side of the real line. And we also have the important F distribution, which, if you realize, is also located on the positive side of the real line, and it actually has a very different organization from the rest of the tables. And that's the most important thing that we will discuss today. So going back to my whiteboard, objective 1, review of chapter 7, and 2, plus. Okay, so now we all know where we are going. I am going to start with a very short, very brief review of chapter 7. Okay, yeah, I think it would be better if I go to here first. So let's look at the index. We are now in the chapter of sampling distributions, and the first question is, what is a sampling distribution? And my answer is, it's the distribution such that it describes how a sample is distributed when we take it from a population. So the key thing is, everything we are discussing in this chapter 7, they're designed to describe properties and distributions of the samples that we use in statistics. So by using these knowledge, when you have a sample, you can jump to some very important preset conclusions. For example, by using the central limit theorem, we can say that if we are drawing from a large population, then the sample would approximately follow a normal distribution with mean mu and variance sigma squared over n. So that's the kind of conclusions that we're looking for. Now, the thing that we are going to focus on today is section 7.2. And if I am going to draw on my little board here, so we were talking about properties of distributions. So 7.2 and 7.3 to 7.5, if I'm, yes, 7.5 are actually two parts of this chapter. 7.2 is talking about exact cases. So these distributions are exact. And 7.3 to 7.5 is based on CLT, and distributions are approximate. So really, as I'm trying to emphasize here, the key thing to this chapter 7 is you need to view it as two parts. Part A, exact, part B, approximate. And in this exact distribution part, let's see over here, so I'm having this on the left side of my screen. You will see that we discussed distributions related to the sample mean. We discussed distributions related to the sample variance, which is where we first see the chi-square distribution. And then we will also discuss, well, combining these two, we have a chi-square distribution with n-1, which is one important concept that we will discuss very soon. And then we introduce, based on chi-squared and normal, we will have the t distribution. And next, based on the t distribution, we will have the f distribution. Sorry, based on the chi-square distribution, we will have the f distribution. Excuse my mistake there. So that's how these things come together, and I'm going to write it as first we have the distribution, and then we go to which is following normal, and then we go to our sampling variance, which will be following chi-squared, and then from there we go to the definition of t, and oops. From chi-squared, we go to the definition of f. And then we will talk about the approximate part later on, I think sometime next week, and we will discuss this very important part. So this is basically how chapter 7 is organized. And next, we want to go to the part on distribution. We've already seen a couple minutes ago that we have the z distribution table, we have the t distribution table, we have the chi-square distribution table, and we have the f distribution. The way I want to organize this is as follows. I personally think that the t distribution and chi-square distribution tables are organized very similarly. Z is different from these two, so they are actually, I would say, mirror images of each other. And then F distribution table, you can just conclude it as complicated, because as I'm sure we've talked about in class, F has 2 degrees of freedom, df1 and df2. You have to incorporate those both in a 2D table. Okay, so now let's look at first our z distribution table, which is located on, now if you would please indulge me, open up your electronic copy of the textbook. Help us a lot in our discussion right now. Hopefully everyone has a copy. Well, if you really can't get a hold of one right now, I guess it would be okay. Just look at my screen. So, I want to change things. So this is our Z table or the normal table. First thing I want to guide you to is this graph over here. Whenever you are given a distribution table, you must first look at this graph. It's usually located on the top of the page. What this graph is telling you is, first off, this shaded region is only giving you up to the right half of this distribution. So if you see here, the largest value in the table is 0.5 and the smallest value is almost 0. So it's going from the point where you are starting out here, and then you're going this, and this way, all the way to the right-hand tail. Okay, so you are not covering anything that's going on here. The second thing I want you to realize is this little z here and this area here. So what this is saying is this z, which is denoted by this column, and this column, basically the index of the table, is denoting those values located on the right-hand side of the numerical line. This is called the critical value. So z, the critical value. I just as well add, and bear that in mind, z is numbers on the real line, and z must be greater than 0 since we are only covering the right hand side. The second thing, like I said, is this area. Area, as we well know, corresponds to the shaded region under the PDF of normal, which means that this thing is corresponding to the probability of an event. And this event is actually, so let me write here. Area is the probability, of, obviously something's not going well. Oh, crap. My apologies, I must have touched something. This is one of the setbacks of using technology instead of chalkboard. Sometimes technology just messes things up. Okay, we're back in game. So we have area, which is the probability. Okay, I give up. I'm just going to write on the chalkboard over here. Oh, geez. Area is the probability of z greater than some set critical value. Okay, that's what I'm trying to say. And this area, like I said, must be between 0 and 0.5, since we are covering the right hand side probability. Because our default, what is going on? Our default is we want to have the probability to the left-hand side, right? Our CDF always gives us probability less than or equal to. But in this case, you will notice that it's actually greater than or equal to. And that is one big important difference. And those areas are represented with these values inside our table, okay? So all these values are representing the probability. So now, if we look at a practice question, okay, we want to find the probability corresponding to a variable distributed as standard normal such that it exceeds 1.23, then I want you to look at first 1.23 here is our critical value, right? So we are given the critical value 1.2 plus 0.03 is 1.23, and then we locate this value here. 0.03 0.1093. And this is exactly the probability of greater than or equal to 1.23, the right tail probability. And we are indeed looking for the right tail probability, so the answer is just 0.1093. So about 0.1 probability, 1 in 10.